In the world of software development, programming languages are the unsung heroes that power our favorite apps and websites. Among these languages, Swift has emerged as a powerful and versatile option, especially for those working within the Apple ecosystem. Developed by Apple Inc., Swift was first released in 2014 and has quickly gained popularity for its modern features, ease of use, and focus on safety and performance. Whether you are a seasoned developer or just starting your coding journey, understanding Swift can open doors to exciting opportunities in the world of iOS, macOS, watchOS, and tvOS app development. Before Swift, Objective-C was the primary language for building Apple applications. While Objective-C had its strengths, it was also known for its complex syntax and steeper learning curve. Swift was designed to address these challenges, offering a more intuitive and beginner-friendly syntax while still maintaining compatibility with existing Objective-C code bases. This means that developers could leverage their existing knowledge and gradually adopt Swift into their projects. One of the key design goals of Swift was to create a language that was both safe and fast. Safety in this context refers to the language's ability to prevent common programming errors that can lead to crashes or security vulnerabilities. Swift incorporates features like strong typing and optionals to minimize the risk of runtime errors, making it a reliable choice for building robust software. Furthermore, Swift was built with performance in mind. Its syntax and language constructs are optimized for speed, allowing developers to create applications that run smoothly and efficiently. This focus on performance is crucial in today's mobile-first world, where users expect apps to be responsive and deliver a seamless experience. Swift's popularity among developers stems from its unique blend of modern features, ease of use, and strong performance. Let's delve into some of the key features that make Swift stand out. 1. Clean and concise syntax. Swift's syntax is designed to be clear, concise, and easy to read. It borrows the best aspects of other modern languages like Python and Ruby, while eliminating unnecessary boilerplate code, making it more intuitive for both beginners and experienced programmers. 2. Safety first. Swift places a strong emphasis on safety, employing features like strong typing and optionals to prevent common programming errors. Strong typing ensures that data types are explicitly defined, reducing the likelihood of type-related mistakes. Optionals provide a safe way to handle situations where a value might be missing, preventing unexpected crashes. 3. Speed and performance. From its inception, Swift was designed with performance in mind. Its syntax and language constructs are optimized for speed, allowing developers to create applications that run smoothly and efficiently. 4. Modern language features. Swift incorporates many modern language features that developers have come to expect, such as closures, generics, and protocols. These features provide powerful tools for writing flexible, reusable, and maintainable code. 5. Interoperability with Objective-C. While Swift is a modern language, it was designed to seamlessly integrate with existing Objective-C code bases. This interoperability allows developers to leverage their existing knowledge and gradually adopt Swift into their projects. Swift's syntax is designed to be clean, concise, and easy to understand, even for those new to programming. It emphasizes clarity and readability, making it easier to write and maintain code. Let's explore some fundamental aspects of Swift syntax. First, semicolons. Unlike many other programming languages, Swift does not require semicolons to end statements. However, you can still use them if you prefer or if you need to write multiple statements on a single line. Second, variable declaration. To declare a variable in Swift, you use the keyword followed by the variable name and its type. For example, declares a variable name of type string and assigns it the value John. Third, constant declaration. Similar to variables, you can declare constants using the keyword. Constants store values that cannot be changed after they are assigned. For instance, declares a constant named age of type int and sets its value to 30. Fourth, type inference. Swift is intelligent enough to infer the type of a variable or constant from the value assigned to it. This means you don't always have to explicitly specify the type, making the code cleaner. For example, automatically infers temperature to be of type double. Fifth, printing output. To display output to the console, you use the function. You can pass variables, constants, or expressions within the parentheses to print their values. For example, we'll print "Hello, John" to the console, assuming the name variable holds the value John. Section 4. Variables and constants, storing data effectively. In programming, variables and constants are fundamental building blocks used to store and manage data. They act as containers that hold information, allowing you to manipulate and work with data within your code. Swift provides a clear and concise way to declare and use variables and constants, making it easy to manage data in your programs. Variables, as the name suggests, are used to store values that can change over time. You declare a variable using the keyword followed by the variable's name and its data type. For example, declares a variable named score of type int and initializes it with a value of 0. The data type specifies the kind of data the variable can hold, such as integers, floating point numbers, strings, or more complex data structures. Constants, on the other hand, are used to store values that remain fixed throughout the program's execution. Once you assign a value to a constant, you cannot change it later. You declare a constant using the keyword, followed by the constant's name and its data type. For instance, declares a constant named pi of type double and sets its value to 3.14159. Choosing between variables and constants depends on how you intend to use the data in your program. If you know that a value will remain the same throughout the program's execution, it's best practice to use a constant. This not only makes your code more readable, but also helps prevent accidental modifications that could introduce bugs. On the other hand, if you anticipate that a value might need to change during the program's runtime, use a variable to store it. Section 5. Functions in Swift reusable blocks of code. Functions are essential building blocks in programming, allowing you to break down complex tasks into smaller, more manageable units of code. They promote code reusability, modularity, and overall program organization. Swift provides a robust and flexible syntax for defining and using functions, making it easy to write clean and well-structured code. A function in Swift is defined using the keyword, followed by the function's name, a set of parentheses that may enclose parameters, and a code block enclosed in curly braces. The code within the curly braces represents the function's body, which contains the instructions to be executed when the function is called. Here's a simple example of a function that takes two integers as input and returns their some Swift func add numbers, num1, int, num2, int. Int let sum equals sign num1 plus num2 return sum. In this example is the function's name. It takes two parameters and both of type. The after the parentheses indicates that the function returns an integer value. Inside the function's body, we calculate the sum of the two input parameters and store it in the constant. Finally, we use the keyword to return the calculated sum value. To call this function and use it in our code, we simply write the function's name followed by the input values or arguments within parentheses. Swift let result equal sign add numbers num1, 5, num2, 7. Print result / output. 12 functions can also be defined without returning any value. In such cases, you omit the and the return type from the function definition. These functions are useful for performing actions or displaying output without necessarily producing a result to be used elsewhere in the code.